Welcome to Pacesetter, the class 10th. The today topic is metal and non-metal, the part 2. Today we will study about the non-metals. What do you understand about the non-metal? The first we should understand the non-metal is a acceptor. It accepts the electron, correct? So non-metal is a acceptor. After getting the non-metal is a acceptor. After getting the electron, they form the negative ion, correct? So the examples of the non-metals are the iodine, sulfur, the oxygen, hydrogen, etc. The next properties of the non-metal we should remember that normally found in the either in the solid or the gas state, correct? Normally found except the bromine, correct? The bromine is at the normal temperature found in the liquid state. The whatever I say the exceptional that you must remember for the MCQ point of the view. Now we will talk about the physical properties of the non-metal. The same we have already discussed the physical properties of the metal. Now we are going to study the physical properties of non-metal. The first is the malleability and the ductility. The malleability you understood, when we hammer it, it becomes the thin sheet. That is called the property of the malleability. Ductility is the property by which it can be drawn into the wire, correct? So the non-metals they are neither malleable nor ductile. Understood? So it is not the malleable and not malleable, not ductile, neither malleable nor the ductile, correct? The next is the brittleness. They are brittle in the nature. Example is a sulfur. They are brittle. If you hammer it, it will become the small pieces, correct? The next is a physical state. What is the physical state? They are either in solid or the gas. Already we have spoken, correct? If solid, then it is a soft in nature. If it is a solid, we find that it is a soft in the nature, except the diamond. The diamond is a non-metal, that is the carbon, the allotropes. That is a hardest natural thing, correct? So that is a being the non-metal allotrope. It is a exceptional case. It is a hardest natural thing. Next is a luster. The luster is a property by which the surface keeps shining. But in the non-metal, they do not have the luster. Means they don't have the shiny surface. The example is the except the iodine. The iodine, carbon allotropes, this carbon allotrope, that is diamond and the graphite, being the non-metal allotrope, but still it is a shining, correct? The next property is the electrical and the thermal conductivity. It is a poor conductor of heat and the electricity, but again exceptional is there. The allotrope of the carbon, that is the graphite, is a good conductor of the electricity, and the diamond is another allotrope of carbon, which is the good conductor of the heat, correct? So this exceptional you must remember it. The next is melting and boiling point. Now I think up to now you are well aware about the melting and the boiling point. It is having the low melting and boiling point, correct? Comparatively higher. It will have the comparatively melting and boiling point higher if it is in the solid state, like silicon, the carbon, correct? The boron. They are the non-metals at the normal temperature and pressure. They are in the solid state, so they have the little higher melting and the boiling point. Next we will see the chemical properties. The chemical properties. Normally non-metals that do not react with the water, the steam water or the dilute acid. In the normal cases, they do not react, correct? They do not react, and like metal, it doesn't evolve the H2 gas, हाइड्रोजन गैस प्रोड्यूस नहीं करता है. क्वेश्चन आता है कि ये हाइड्रोजन गैस क्यों नहीं प्रोड्यूस करता, क्यों नहीं प्रोड्यूस करता? यस, देयर इज अ रीजन. व्हाट इज द रीजन? इट डजंट इवॉल्व द हाइड्रोजन बिकॉज दे आर द electron acceptor. As you know, when the H2O when the any of the acid breaks down, there is a formation of the H ions, correct? So there is a formation of the H plus ion. If it gets the electron, it will convert into the H2 gas. But here it is a being the electron acceptor. It doesn't give the electron to the H plus ion. So it is not getting converted into the H2 gas. Okay. Do not give electron to the H2 and the acid reduced to the, so it doesn't reduce to the H2. But if it is heated, in the presence of the concentrated acid means the acid which is the pure form, the acid which doesn't have the water content, correct? When it is heated, then it can it can make the oxide or there the salt, correct? We can see the sulfur plus the H2SO4 conc. If it is heated, it is going to make the sulfur dioxide and the H2O water will be made. If the sulfur is heated with the presence of the 6 molecule or the 6 molecule of the nitric acid, conc nitric acid is going to form the H2SO4 plus NO2 and plus the H2O, that is the water. This is the nature of the chemical properties of the non-metal. One more thing we should understand, it also shows the displacement reaction. One example we can see, the chlorine gas plus the sodium bromide, the NaBr, when it reacts, it is going to make the NaCl and the bromine gas. Understood? One more, the most of the non-metals form the oxide, they are acidic in the nature. They are acidic in the nature, correct? When it is dissolved in the water. Next property we will see the reaction between the metal and non-metal. Gentlemen, normally we understand that metal is a donor and the non-metal is a acceptor. Donor means which can donate easily, which can release, which can easily with the less energy, which can leave the outermost electron, correct? So they are the metals. The non-metals are one which is ready to accept the electron. So they are the acceptor. Correct? So in the metal and the non-metal, the reaction which is taking place is said the ionic bond. The bond, correct? The bonding is called the ionic bond. The ionic bond is the bond in which the two different elements makes the bond, that is the positive and the negative, they make the ion, correct? So here we will see the how the chemical reaction between the metal and the non-metal is taking place. We see the sodium is a metal. The sodium is a metal. We know that is atomic number is a atomic number of the sodium. Anybody can say it is a atomic number is 11. Means it is having the total number of the electron 11. The total number of the proton, it is 11. When we do the configuration of this electron, then we will find that the sodium Na will have first orbit will have the 2 electron. In the second orbit it will have the 1 2 3 4 5, 6, 7 and the 8, and the next it will have the 1 electron, correct? So it is a 1 electron. If you calculate, this is a K, L and the M. So this is a K is the inner cell which can contain the maximum 2 electron. The L will have the, we know the formula is a 2n square. The n can be the 1, 2, 3, 4, correct? This all already you know it. So in the outermost orbit, we have the 1 electron. The sodium is in tendency to lose the 1 electron, correct? And we have the another. So when it is losing the 1 electron, this electron is out. Can you see it? Then it becomes the Na plus. The question is to understand why it becomes the Na plus. It becomes Na plus because now the Na has got the 2 plus 8, total 10 electron, because it has lost the 1 electron, correct? Whereas the total number of the electron, now it has got the electron 10, whereas the proton remain 11 only. So the domination by the 1, correct? Can you see the 1 proton is extra, having the positive charge, correct? So it is losing, so it becomes the Na plus, because 1 proton is extra in their nucleus, correct? So this is called the sodium, the cation, which is losing the electron, become the positive by nature. So this is the sodium, the cation, correct? The next we will see the chlorine. The chlorine is having the chlorine. The chlorine, we can have the first orbit, we can have the, this is nucleus, if you say nucleus. The first will have the 2, the second will have the second orbit or second cell, 1, 2, 3, 4, 5, 6, 7 and the 8. Total we know that the 17 is there, 2, 3, 4, the 5, 6 and the 7 is there. The atomic number of the chlorine is 17, correct? So when you do the electronic configuration, you get 2, 8 and the 7. The 7 is a number of electron present in the chlorine. Understood? So you should understand, it becomes easy to accept the 1 electron than to release the electron. Understood? So it is in the mood, it is always in the accepted mode to accept the 1 electron. Gentlemen, you should remember that every element when it reacts is try to get the stable. It try to get the stable to make the outermost orbit to satisfy their orbit in the either 2 electron, the 2 electron or 8 electron. If they have only one cell, correct? Only one cell, then they will have the, if there is only one cell, then you will find that only one cell, then you will find that 2 electron can be in the outermost orbit. But other than the K cell, always they are in the tendency to make the 8. The 8 can be made by sharing. If they are doing the sharing, we say the covalent bond. Here they are donating and the accepting, so they are making the ion. So the by losing the 1 Na, that is a salt, that is the metal, has become the Na plus, and the chlorine by accepting the this 1 electron, it has become the Cl minus. Here also you can find that the proton remains 17 only, the proton, and the electron has become 18, correct? 18 electron. So the 1 electron is a plus, that 1 electron is a extra, 1 electron is there. Because of the extra electron which is negative in the nature, so it becomes the Cl minus. When it is a Cl minus, it forms the chloride, that is the anion. The anion, except after accepting, it has become negative, so anion. This sort of the bonding is said to be the ionic the bond, because there is a formation of Na plus and Cl minus. If you take the other example of the magnesium, there also we have the magnesium is having the 12 atomic number. The outermost orbit will have the 2. It will donate it will release the 2 electron and the chlorine will accept it, correct? So when it reacts, it is going to make the NaCl, correct? When both are reacting, it is going to make the NaCl. Remember, in the NaCl, the Na is a plus and Cl is minus, correct? So they have made the ions. So this sort of the bonding is said to be the ionic the bonding, correct? Ionic the bonding. Now we will see the what is the properties. The what is the properties of that? The ionic bond, the properties, correct? The ionic bond property we will see the one by one. The first we will see the physical nature. Physical the nature. Here we will see the ionic bond, correct? Ionic the bond. The ionic bond. What is the property? In the physical nature, what we see? The ionic compounds are the hard crystalline solid. They are the hard crystalline, correct? The crystalline, hard crystalline solid. They are the hard crystalline solids because their attraction forces. You have seen the Na plus and Cl minus is there. So this attraction force is quite effective, correct? Quite effective. So because of that, they are very hard in the nature, correct? These compounds are generally brittle and the breaks into the pieces when pressure is applied. So they the hard crystalline, the solid is there. The brittle, normally it is a brittle in the nature, correct? And breaks into pieces when you apply the more forces. Understood why they are the brittle, why they are the hard? Because ionic bonds, the attraction forces are more effective, correct? Next, the melting and boiling. Melting and boiling point. The melting of the boiling point, what will happen? This will have this compound has a high melting. It will have the high melting and the boiling point, correct? It will have the high melting and the boiling point because of, again we will say, because of the energy, because of the attraction force. If the bonding is a proper, if there is the ionic bond, their attraction forces are so effective that it requires more energy to break it, correct? So it has got the high melting and the boiling point. The third, what is that? The solubility. The solubility. The solubility of the ionic bond. These compounds are soluble in the water. Soluble in the water. It is soluble in the water because water is a polar. The polar water is a just solubility. These compounds are soluble in the water because they are the polar, the solvent, correct? The polar solvent. You should understand. This is the ionic bond. There is the ions are formed Na plus Cl in the normal any other compounds. If you are putting, it is not going to dissolve it. But if you put in the water, because the water is also a polar solvent, water breaks into the, the water also breaks into the H plus and OH minus, correct? So it is also the polar solvent. So because of being the polar solvent, it will dissolve. It will be soluble in that, correct? Uh, and insoluble. And it is insoluble. It is insoluble in non-polar solvent. So what is the non-polar solvent? The kerosene. The kerosene oil. The kerosene oil is a non-polar solvent. The benzene is a non-polar the solvent, correct? The benzene is a non-polar water. Okay, so you understood. So it becomes the soluble only in the water because this is also the ionic bond means it is also having the polarity, and H2O is a polar because it breaks into the H plus and OH minus, correct? It is not dissolved, it will not dissolve, insoluble in the non-polar solvent like kerosene and benzene, etc. The fourth property we will see, the conduction of the electricity. Conduction of electricity. Now you should understand the conduction of the electricity, though a solution involves the movement of the charged particles, ionic and the electroviolet, the compounds are the good conductor of the electricity. They are the good conductor of electricity. They are the good conductor of the electricity. Remember, they are the good conductor of the electricity because they do not have the free electron, but they have the ion, correct? They have the ion as a carrier. They have the ion as a carrier, so it can conduct. But remember, if it can conduct only when they are liquid or in molten state, correct? Molten state. If it is solid, it is not going to conduct, understood? So you should remember that way, correct? A soluble the ion compound the work contains all, okay, because of the ion, understood? So in the molten form, the electrostatic form of the attraction between the opposite charges iron overcome due to the heat, okay. So we should understand the conduction of the electricity, how it happens, correct? The next, the occurrence of the metal, okay. Gentlemen, today I am concluding. Thank you very much. Please do subscribe, like it and pass the comment. Thank you.